We've already talked about solving exponential equations. This is more a review than anything else, but also last time we talked about these, the problems that you guys did were very basic, I would say. You're going to see some things that are a little bit more involved, but are still treated the same way. Okay? And so to start, here's what you need to know how to do. First, if you don't have the same base, you want to make the bases the same. Okay? That part we've talked about. Once you have the same base on both parts of the equation, on both sides, then you're going to set the exponents equal to each other, which that we've done. It's just we haven't done too many that are that complicated. Okay, and in case you're more of the property person, here's the idea. If you have the same base on each side, doesn't matter what the bases are. That's why we have A here and A there. But as long as they're the same, whatever these exponents are, have to be equal. Okay, that's the assumption. Okay, so we'll start from the beginning and cruise through this. Here, we already have the same base. So what can we say right away? 2x must be equal to 16. Yes. So x is 8. Okay. That we've seen already, right? Pretty comfortable with that. 3 to the minus x, 27. Can we change 3 at all? We can change 3 to what base? You can't go higher. You can make the base smaller, though. So 3 is already good, but I like what you said there. You know that 27 is related to 3. What is it? 3 to the third. Okay? And look, if you don't know your powers, you have calculators. You could just sit there and go, okay, is it 3 squared? Is it 3 cubed? Is it 3 to the... Oh, it's 3 cubed. Okay. Once you know that much, then again, it's set the exponents equal. Negative x must equal 3. In other words, x equals negative 3. Okay? Bless you. Let's try this one over here. Okay? 6, you can't really make that into a different base. Okay? 1296, however, you can. Is it 6 to the 4th? Okay, so 6 to the 4th is the same as 1296. So the 1296 gets rewritten as 6 to the 4, but you still got to have that little x on the outside. Does that make sense? So on the left we have 6 to the x squared. On the right, what do you do with these exponents once they're written like this? You multiply them. So now we get 6 to the x squared equals 6 to the 4x. So that means that x squared must equal 4x. Okay? And if we learn anything in this class, I would just hope that you guys remember, as soon as we see higher exponents, squares, cubes, and all that, the first thing you want to do is move everything over and set it equal to 0. You can take the square root as long as there was no x over here. So if it were like this, that's a different story, right? But if you see x squared and you see x or x cubed, you know, like a whole bunch of them, just move everything over and set it equal to 0. So I'm going to go over here and do that. All right, and now how do you solve that? Take out the x, very good. What's left? Good. And so we have two solutions. From here, we know that x is 0, and from this one, 4. Okay, and again, you guys know that you can check these answers, right? Like you can just type in the left side of the equation, 6 to the 0 squared equals 1296 to the 0. Of course, it's going to work. And then type in the 4 if you really want to make sure. Okay. Wendy, could you close the door? Thank you. Okay. Why don't you guys try this one over here on your own real quick? All right, what base are you guys using? Does 8 work? I don't think 8 works, you guys. It's, yeah, because 8 is going to give you either 8, 64, and then after that it's 512. Okay. 4 I think works though. 4 to what power? To the 4th on this side? Okay. And then 64 is 4 to the what? To the 3rd? Okay. And now we just want to be careful here. You're going to simplify first before you start solving, okay? What's this exponent going to become? Good, 12x. Here we get 4 to the what? Good. Make sure you distribute. Now you can set them equal. 12x has to equal 3x plus 3. Move the 3x over. 9x equals 3. Divide by 9. 3/9, right? Which reduces to 1/3. Okay? Let's look at G real quick. Okay, so like I said, these are all things that I hope you're comfortable with. It's just some of these problems will get a little tricky, but nothing that you guys can't handle, okay? Here we're not actually solving for x. We're trying to figure out what this equals. Okay, so I'm actually going to just start by writing down 11 to the x equals 5. Okay? If you compare what we know to what we're looking for, what's the difference between 11 to the x and this 11 to the minus 2x? What's the only difference? There's a minus 2 in the exponent, right? Well, according to algebra, we can certainly put a minus 2 exponent in there, right? As long as you do it to the other side, right? So now we get 11 to the minus 2x. And then 5 to the minus 2 is really 1 over 5 squared, or 1 over 25. Does that make sense, you guys? Yeah. Okay. Let's look at I real quick. Boy, aren't they nice with this one? I mean, if you don't know what base to try, I hope you would look at this and go, I probably want to work with base 4 to see if that works, right? 64 is 4 to the 3rd, so change that up. Leave the 2n plus 1 on the outside. 16 is 4 squared. Leave the minus n minus 2 there. And that's supposed to equal 4 to the 3. Can't do anything yet until we simplify the exponents. So on the top, you'd get 4 to the what?
6.
Good. And then on the bottom, 4 to the negative 2n minus 4. And that equals 4 to the 3. I'm going to kind of slide on over this way because I want to do this one here. When we're dividing, remember the rules for exponents. When we divide the same base, what happens with the exponents? You subtract. Absolutely. So you know what I'm going to do? I'm going to go ahead and just write off to the side 6n plus 3 minus, and I'm going to put parentheses around this so I don't mess it up, the bottom exponent, negative 2n minus 4. Okay? And if you distribute the negative, this is really a plus 2n and a plus 4. So if you combine all your like terms, you're left with 8n plus 7. And so that is your final equation. One more step. Now on the left we have 4 to the 8n plus 7. And that's supposed to equal what's on the right, which is 4 to the 3rd. I think once we get it here, you guys know what to do, right? Set them equal. 8n plus 7 must equal 3. subtract 7, you get 4, divide by 8, n is going to be 1/2, right?
Wait, is it a negative?
Oh, thanks you guys, yes. 3 minus 7 is definitely not positive 4, it's negative 4. So then that should be a negative 1/2. I like when you guys are actually paying attention. Okay, that's good. Make sense? Yes.
Yes, at the bottom of the fraction, you can put everything up, and then it can equal into 1 equation. Because at the bottom of the fraction, like you can put everything on top.
Yes. Yeah, just so, I mean, I know it looks more complicated, but think of it like if you had, x to the 5 over x to the second. What's that going to be? X to the third, for many reasons. You could write out x 5 times and an x twice, and you can cancel out, what's left, 3 of them, so it's x to the third. The other option is the property is just x to the 5 minus 2, okay? And so when you're doing that subtraction property, you would just leave the x on top and subtract your exponents. Make sense? Okay, let's do this one real quick. These last two are about as hard as I think these will get. So if you guys are pretty comfortable with these, I think you're good to go. We'll just do one application or two, and then we'll be done. Okay? 3 to the r, should I mess around with that? What about the 81? What's 81? 3 to the 4, good. And and what's 9? 3 squared. Might as well change that up. Okay, I can't set exponents equal yet because I still got work to do on the left side, right? 3 to the r is good. What can I do with these right here? Multiply them, so that'll be 16 minus 16r. And now we have the other property of exponents. When we're multiplying, what do we do with these? You add them. So if you guys are okay just adding them, either in your heads or because it's just addition. I hope you guys can do that. R, what would I add that with? The minus 16r, right? So what's 1 minus 16? Negative 15r plus, what else do I have? The 16. Okay, it's just combining like terms, right? Once you got this, set them equal. So negative 15r plus 16 must equal 2. Subtract 16. 2 minus 16 is negative 14. Divide by negative 15. Your negatives cancel out, and you should get r is equal to 14 over 15. Okay? All right. Real quick, let's go through at least a couple of examples here with the applications. So look, you're going to see some word problems, but they're actually not, I don't think they're that hard. They give you the formulas. The harder part's going to be later on for us when we actually have to find the formula on our own and then work with it. Right now you just need to know what to plug in and solve, basically. Okay? So here you have this formula. P equals 100 times 0.9 to the n. And in the problem, they say P is the percent of the light that passes through, and n is the successive panes. So that means it's basically the number of panes. Okay? And so when you're doing these problems right here, as long as you know what variable they're giving you, you just plug it in. What variable are they giving you here? 10 is which letter? N. So if we're looking for what percent of light, basically we're just trying to find P, right? P is going to equal what? 100 times 0.9 to the 10, and what is that? 74.34. Sorry. 0.87 about. Okay? This one, similar. I'm not going to do it. You understand what to do there, right? Okay, let's go on to the last problem. So now we have D can be used to find the number of milligrams of a certain drug that is in the bloodstream H hours after the drug has been administered. Okay, so D represents the number of milligrams of a certain drug in the bloodstream, and then H is the number of hours. Okay? Instead of actually doing these to save the time, what would we do with this? Just plug it in. 3, I guess we could just do it. E to the minus 0.3 times 1, okay? And this would be the same exact thing, but the only difference is instead of 1, we plug in 9, right? And so just to make sure you guys type these in correctly, again, E is either above the division button or above the natural log button. If you have that feature where your exponent is automatically raised up on your calculator, then you're good. If you guys have carets, does anybody... Does anybody see... Oh my gosh, mine doesn't even do it. Does anybody see 3E with a little caret, upside down caret? If you see that, you just need to make sure that you put extra parentheses around your exponent. Okay? If you don't have that feature on your calculator where the exponent gets automatically put in as an exponent, make sure you put extra parentheses in there. Okay? If you do this correctly, here we have 2.22 milligrams about. Is that what you guys got too? Yeah. Okay. What about this last one here? Anybody do that one yet? Point 0.20 about. Okay. Make sense? Okay. I think that's a good place to stop. There might be a problem like this one on Math Excel, but you know, when we have time, we can go through that together if you guys can't figure it out. But it's very similar, and it brings in, I like this one. It brings in a nice little review question with that limit stuff that we did a while back. Okay.